Good evening, students. I welcome you back for another important story lecture on structure of the atom. That's a lecture. We have seen the story of atom is very interesting and it's just like a Hollywood movie students. What we see, how it began, everything began about 200 thousands of years ago. Otherwise I'm not saying that, but most of the discovery 200 years back, student, the first discovery was the discovery of the electron by J.J. Thomson. Interesting that every matter is made up of very tiny small particles which we call as atom, students, and Dalton 1803 has given his atomic theory. At that time in 1803, that was the information which was available, and Dalton's theory was very good at that time. And many points of Dalton's theory are still valid, students. You know about that. But as experiments were being done on discharge through gases, it was J.J. Thomson who discovered the first subatomic particle. We know about it. Is it right or wrong, student? The first, I am saying, discovery of electron. That is the first subatomic particle which was discovered. Who discovered electron, students? Who discovered? J.J.
J.J.
Thomson.
Thomson.
Okay. And after that, what they found? Charge of the electron, charge of the electron and mass of the electron. ठीक है? This we was determined after from experimental information from after doing experiment. These were determined. And then students, what happened? You have heard about that there are canal rays and there was discovery of protons, which are positively charged particles. And Thomson proposed his model, Thomson's atomic model, which was rejected after which experiment? Which experiment was done on the basis of which the slump pudding model, a model of the atom in which he says positive charge is present throughout the center of a sphere and electrons are embedded into, was rejected. Important experiment was done by which scientist, student? What scattering experiment? What is the name of that? Rutherford scattering experiment, alpha scattering experiment. What he did? Alpha scattering experiment, students. What was the most important conclusion or result of the Rutherford scattering experiment? What was discovered, students, by Rutherford? Discovery of nucleus. That there is a entire positive charge inside the atom is present inside the nucleus, students, and also almost all the mass of the atom is present inside the nucleus, as the mass of the electron was around 1 by 2000 times that of the proton. Very important, which we find the mass of the electron is very, very small, and it is about 1 by 2000 times that of the proton. Mass of the electron, you are saying the mass of electron is about 1 by 2000 times that of the mass of the proton, student. And further, student, Rutherford proposed his own model, Rutherford atomic model. Then he came forward with Rutherford atomic model. What it said? Electrons are orbiting around the nucleus. What was the main problem? What was the main limitation? What was the main drawback of the Rutherford atomic model? It could not explain the stability of the atom. The main problem was, student, electrons are charged particles. When they are accelerated around the nucleus, they will emit radiation, they will emit energy, and will immediately in less than 10 minus 8 seconds, they will go and collapse inside the nucleus. Therefore, Rutherford atomic model failed because it could not explain students the stability of the atom. And you know that atom is stable because the matter exists. If atom is not stable, then matter will not exist in the form in which we are experiencing. Therefore, it could not explain the stability of the atom. And then came Neil Bohr, student, Neil Bohr. And in order to overcome the drawbacks of the Rutherford, Neil Bohr proposed his own postulates, which is called Bohr's atomic model. Bohr's atomic model, students. Bohr's atomic model. What was the Bohr's atomic model? The main purpose was to overcome the limitations, the drawbacks of the Rutherford model. What he said? He said that there is a nucleus and electrons are moving in orbits around the nucleus, and he said that so long as electron moves in an orbit, in a fixed orbit which has definite energy, which is also called energy level, it will not emit or absorb any energy. So electrons are only moving in certain allowed orbits. What he said? That there are only certain allowed orbits, what we call as shells, what we call as energy levels, in which the electrons in which the electrons are orbiting around the nucleus. Electrons are orbiting around the nucleus. That means, student, and we have given you that these are indicated by letters, how they are named, students. You are saying n value is 1, then it is called K. If n is 2, it is called L. N equal to 3 is called M, and so on. So we give names to them: K shell, L shell, M shell, K, L, M. These are the shell, students, which are present outside the nucleus, in which electrons are orbiting. And also, students, the important point is that this discovery is very, very important, because our main purpose is, students, to find the distribution of electrons around the nucleus. How electrons are distributed around the nucleus in different shells is a very important point, student. Very, very important point, which we want to, we will show you. What is my question to you, student? What we are trying to explain, what the Bohr's theory was able, Bohr and Bury. There are two scientists, student, Bohr and Bury. Both have given, suggested that how the electrons are distributed, how the electrons are distributed, students, how the electrons are distributed in different orbits, in different orbits, what we call as shells. Which shells? You are saying K, L, M, N. How electrons are distributed in different shells or different orbits. They are also called energy levels. So they have given a scheme in order to tell you that how electrons are distributed in different shells around the nucleus. Around the nucleus. So the important point to note is, students, that this is very important for chemistry point of view. Why? We will tell you very soon. Because if I know the distribution of electrons in different shells around the nucleus, we will be able to find the electronic configuration of the elements, students. What do you mean by electronic configuration? Because you know atoms are combining. Atoms combine to form molecules. Atoms are combining to form different type of compounds, students. And then we will be able to explain how the atoms combine and what is the combining capacity of different atoms. Combining capacity, which we call as valency, that we can also explain on the basis of the distribution of electrons in different orbits, students. So therefore, what they said, there were certain rules which were proposed by, which are also called postulates. These are called the postulates, students, which were given by Bohr and Bury. Bohr and Bury. These are the two scientists, students. They have given postulates. They have given certain rules, students, for the filling of electrons in different shells around the nucleus. What they said, the maximum number of electrons, the maximum number of electrons present in a shell is given by which formula, student? Tell me the formula we have given you last time. What was the formula which was proposed? What is the maximum number of electrons present in a shell? What is the formula, student, which we gave you last time? Tell me. N can be 1, 2, 3, 4, and so on. When N is 1, this is called K shell. This is our L shell. This is M, N, and so on. These are our shells, students. And I told you in these shells are living the electrons around the nucleus. What is the maximum number of electrons which can be present in a shell? What is the formula, student? 2n square. What is that called? 2n square rule. This is the formula, student, which we are using. In other words, student, for K shell, what is the value of N for K shell, students? N equal to, tell me, for K shell, what is the value of N? For L shell, what is the value of N? For M shell, what is the value of N, students? 1, 2, 3, and so on. We have given it here. So what will be the maximum number of electrons which are present in K shell? What will be the maximum number? You have to use this formula, 2n square. 2 into 1 the square. How much will that come, student? 2 in the 2 the square. How much it will come? 2 into 4. How much it will come? 2 into 3 the square. So like this we can calculate, student. What is the value coming? 2, 8, 18. If n is equal to 4, KLM n shell. N shell. How many electrons you are going to put here? 2 into 4 the square. How much it will be? 2 into 16, 32. This is the maximum number of electrons that can be present in a shell. 2n square rule, students. Similarly, you can keep on calculating if you have more electrons and you know how many elements are existing and how many electrons you will need. We are going to discuss slowly all these things as we keep on studying more and more science and chemistry, students. So maximum number of electrons is known. An important point is, another important point is the maximum electrons, students. The maximum electrons that can be accommodated, student, in outermost shell, in outermost orbit is 8. Now this is something important point to be understood, students. What this means, student? I am putting a red mark on this. What do you mean by this? How do we understand this? I am saying this is the maximum electrons which I have calculated, 2, 8, 18, 32. And now I am saying that maximum that can be accommodated in outermost orbit is 8. What it means? All I want to say that till date in your 9th class, we are saying there are shells, K shell. This is n equal to 1. L shell, student, I am saying there is a L shell. N equal to 2. M shell, what you are saying? N equal to 3. N shell, what you are saying, students? N equal to 4. And in these shells, student, there are subshells actually, which we have not shown you in this class of 9th, which you will learn later, that inside the shells are also subshells. There are subshells. Just like you enter a building with 10 floors, but each and every floor has many flats. First if you enter a building which is very tall and 10 floors, and you go to the first floor, you find there are four flats in the first floor, and there are four flats in the second floor, there are four flats in the third floor. And then this means, this is what I'm saying, shell is there, but inside the shell there are subshells in which the electrons will go. And in the subshells there are orbitals, which we will learn, students, which will we learn in the next classes. There are orbitals, students, in which the electrons live. There are orbitals, and that is why, student, when we write to 8, 18, 18, this is the total shell, but there are subshells and there are orbitals inside the, which are present inside every shell. So they are represented by S, P, D, F. These are called the subshells or orbitals in which the electrons will go after they enter a particular shell. In K shell, we are saying n is equal to 2. So what is the maximum number of electrons here? Maximum electrons in K shell are 2. In here, how many? We have shown 8. Here, how many shown? 18. And n equal to 432. This is the maximum electrons which can be there in K shell, L shell, M shell, N shell. But what happens? In K shell, you have only one orbital, one s. So you have only one s, student, s orbital. And in s, only two electrons can be there. It has two electrons in s orbital. And in the L shell, you can have two orbitals. One is s and other is p. So there are two orbitals in 2s. Since it is n equal to 1, I'm saying 1s, 2s, and 2p orbital. In 2s, you can have 2 electrons, and in 2p, you can have 6 electrons. When n is equal to 3, in the shells, there are orbitals, there are subshells. Here I'm saying there are 3s, 3p, and 3d, 3s, 3pd. In 3s, you can have only 2 electrons. In 3p, you can have 6 electrons. In 3d, you can have 10 electrons. What is the total number now? 6 plus 2, 8. 8 plus 10, 18. What is the total number here? Here only one orbital, 2 electrons. Here 2 plus 6 will be 8. And 2 plus 6, 8. 8 plus 10 will be total. Total how much? 18. Total is 18. And here similarly I can find, student, there will be 4s, 4p, 4d, and 4f, supposing. And how many electrons in s? In 4s you can have 2 electrons. In 4p you can have 6 electrons. In 4d you can have 10 electrons. And in 4f you can have 14 electrons. What is the total? 8 plus 10 plus 14, 32. This is the story. This is not shown in your 9th class NCERT book. This is an information which I am giving to you, student. You can note it down. Why do we say like this, and what is the use of 8? Why we are talking of 8, student? We will explain more about this very soon. Because 8 is a very stable state. As I said, the filling of electron takes place in such a way so that the energy of the atom is minimum. Did I say yes or no? The electrons will be filled so that the energy of the atom is minimum. So the third point was, what was the third point here, students? The third point was, what was the third point, students, in this theory, which was given by Bohr and Bury theory? What they say, that electrons first will go to the inner shells. Electrons are first are filled in inner shells first. What do you mean by this? Inner shells first, or lower energy levels first. Lower energy shells or levels first. So first the electrons will go to lower energy. After lower energy is filled, they will go to the next. And after next is filled, they will go to higher, like this. Or in other words, student, in other words, what we are saying, what you are saying, student, I hope the point is clear. Student, you have noted down this, that what I want to show you. For example, this is a nucleus. Supposing this is our K shell, students. And supposing this is your L shell. Then you have which one?
K, L, M. After this, you have N shell. So first the electrons will enter K because it is lower in energy, lower in energy. Then they will go to M. How many? Here K you have only two. Here M how many you have? One, two, three, four, five, six, seven, eight. Like this, you will keep on filling. After this is filled, they will go to higher. So first the inner shells will be filled, then will fill the higher energy levels. Because the condition that atom is stable means that energy should be minimum. Minimum energy will be obtained when electrons will fill from lower energy to higher energy. Students, when lower energy level K is filled, then we'll start the filling of the L, and after L is completely filled, the next electron will go to M. It depends on how many electrons are present in the element. If there is only one electron, for example, hydrogen has got only one electron. So where it will go? It will go to first one. Okay, that's all, because it has only one electron. And if I say it is carbon, carbon has 6 electrons. So in K, there can be 2 electrons. After that, 4 electrons will go to the next shell, students. But filling will start from the lowest energy. From the lowest energy. So inner shells will be filled first, then they will be filling the higher shell, student. Is it clear, students? Tell me. Is this point clear, students? Tell me yes
Yes,
or
sir.
no. This part is not in your course, but I have tried to tell you why we are talking of 8 only, and though there are 18 electrons coming. What is why we said this? We will tell you, because it has to do with the combining capacity of the element or valency of the element, which will be discussed in this lecture. Okay, therefore student, if we have to use this scheme, students, the we can start writing the atomic structure. By this scheme, what we can do, student, we can write the what I am saying, by using this scheme, student, which we have told you. Here is a, I'm saying, electronic configuration of elements. The electronic configuration of element means the arrangement of electrons in different shells and subshells. I am saying now there are shells. Inside the shells you have subshells. What subshells we have shown you? S, P, D, F, small ones. So when we are able to write the electronic configuration, there are set of rules to remember for distribution of electrons in different orbits. Electron shell, K shell has maximum of 2 electrons. L shell will have maximum of 8 electrons. We have shown it 2n square formula. For K shell, what is the value of n for K shell, students? N is equal to 1, n is equal to 2, n equal to 3, n equal to 4. And what is the formula I have used, student, for calculating the maximum electrons? 2n square. Got it? Now this is, remember to you, how many maximum electrons? 2n square. 1, 2 electrons. 2 the square 4, 4 into 2, 8. 3 the square 9, 9 into 2, 18. Like this we can calculate by using this formula, student. I have applied which formula, students? 2n square formula. What is the value here? K shell, this is my 2n square formula. So this is 2 into 1 the square. What is this? Is 2 into 2 the square, 2 into 3 the square, 2 into 4 the square. Okay? These values will come. Yes or no? Tell me. Did I do any mistake? Can you
No,
calculate
sir.
this value? Formula 2n square.
Yes,
Important
sir.
formula for finding the maximum number of electrons. Now the outermost shell cannot have more than 8 electrons, even if it has capacity to take up more electrons. Though there are 18 electrons, as you said, 32, but maximum can be 8. This is called octet rule, because the stability of the atom is important. One second thing is atoms combine to form molecules and compounds. And why do they combine? They combine to complete an octet. Octet rule we will explain to you. This is the reason that atoms are combining. And those elements which are completely filled octet in their shell are stable elements like inert noble gases. Helium, neon, argon, krypton. They are very stable molecules and they are very stable gases, student. They are monatomic gases. Helium, neon, they do not combine, they are not reacting, they are very stable because they have complete octet. They have complete octet. This is called octet rule. Octet rule. Outermost shell, octet means stable atom, stable configuration. So atoms want to achieve octet. That is why they are reacting, which we will explain. Therefore, there are subshells. What are the subshells in the shells and subshells? These are the subshells which I told you: sp, spd, spdf, and maximum electrons can be like this. S can have 2, P can 6, S2, P6, and D can have 10 electrons. S can have 2 electrons, P6, D10, and F can have 14 electrons. So only 4 subshells are being used in our case because the total number of electrons are not going to be more than 100 or 110. 118 elements have been listed in the periodic table. That's all. You don't have elements beyond that because they will not be stable. They will not be stable. Something is not stable, it cannot exist. So by using this scheme, students, by using this scheme, we can write the atomic structure of first 18 elements. So let us see how can we write the atomic structures of first 18 elements. First 18 elements. Let me see how can I write the using the rules given by Bohr and Bury. Rules have been given by whom? Bohr and Bury. Postulates. How many rules I have told you? 3 rules. Okay? And we can use this for the atomic structure. Atomic structure. What do you mean by atomic structure? Distribution of electrons in different shells. Atomic structure means distribution of electrons. Distribution of electrons in different orbits or shells was given by Bohr and Bury. The formula I have told you: maximum 2n square and maximum 8 in the outermost. Maximum 8 in the outermost, you are saying. So for example, if I say, if I have to draw the atomic structure of supposing hydrogen, student. Hydrogen is an element, student. Hydrogen has got one proton and one electron. We are going to show you the calculations of proton, electrons, and neutrons also. Atomic number, mass number, in this chapter we will be talking. We know there is one electron in the hydrogen. Okay? Hydrogen has one electron. How will we draw then atomic structure of hydrogen? You are saying this is the nucleus. Okay? Nucleus will contain one proton. And where the electron will go, tell me which shell the electron will go in the hydrogen, students. Which shell the electron will go in the hydrogen? Tell me, students. Fast. First shell is K. How many electrons? 1. Okay? That's all. 1 electron is present inside the hydrogen. How many electrons? This is a K shell. Which shell is this, student? K shell. For this, n is equal to 1. For K shell, n is equal to 1. 1 electron. You have 1 electron in the hydrogen atom. Okay? Next, I come to student helium. This is my helium student. Tell me how many electrons are there in helium. Helium has got 2 electrons. What is the maximum electrons which can come in K shell? Tell me, students. What is the maximum electrons that we can put in K? How many maximum electrons can we put in K? 2n square. How many? 2. So what will be the structure, atomic structure of helium? Atomic structure of helium. How many electrons, students? 2. Now there are 2 electrons in the helium. 1 and 1, 2. 2 electrons. Okay? Now I come to the next element, student. Supposing I have to draw for carbon. I am saying draw the atomic structure of carbon. I am giving you 1 minute, student, to answer this question. Write the atomic structure of carbon. Atomic number is 6. Carbon has 6 electrons. Tell me how many electrons will go to the K and L. Fast 1 minute question. Now we have to draw the atomic structure of carbon, students. How many total electrons? 6. And distribute them in different shells according to the rules which we have told you. According to the rules, student, distribute 6 electrons in different orbits. Tell me, carbon, I am drawing like this. This is my carbon, student. Nucleus. Which is the first shell, student? Which is the first shell? Tell me. K. How many electrons I will put in K? Tell me. What is the maximum electrons in K? Next shell is L. Next shell is what, student? L. Tell me, how will we distribute electrons, students? How many electrons I will put in K shell? Tell me fast. Tell me, how many I will put in K shell? First shell. First shell, what is the maximum electron? 2. After that, can I put more electrons in the K shell? Tell me. Can I put more than 2 electrons in the K shell? Yes or no? Tell me, students. What is the maximum number of electrons that can be accommodated in the K shell? 2n square formula, only 2. How many electrons are left then? 4. Where will they go? This is filled. This is filled. The next will go to where? Next one, how many are there? So in the case of carbon, student, carbon, I can say that the distribution of electron is like this: 2 electrons and 4 electrons. How do we write? For carbon, 2, 4. So the electron distribution of carbon, you are saying carbon, you are saying 2, 4. This is K shell, this is L shell. Any doubt? Tell me, students, you have any doubt here?
No, sir, no doubt.
Okay. Next, I am coming to draw the atomic structure of oxygen. How will you draw oxygen? What is the atomic number of oxygen? What is the number of electrons? I am saying atomic number is also number of electrons. I am saying in oxygen we have 8 electrons. So draw it. You have 1 minute. 1 minute, students. Nucleus. K shell, L shell, KL. First shell can have how many electrons? 2 only. After 2, how many are left? 6. L can have how many maximum? 8. So how many you will have? 1, 2, 3, 4, 5, 6 electrons. Okay? So for oxygen, you are saying KL 2, 6. So oxygen electron configuration 2, 6. I say this is the electronic configuration of the oxygen, students, of the oxygen. 2, 6. 2, 6 student. Now I'm saying draw the atomic structure of aluminium, number of electrons, students, 13. Then I say for sulfur, number of electrons or atomic number 16. Then I'm saying chlorine, atomic number 17. You have to draw the atomic structure of these elements, student. Atomic structure of these elements you have to draw. We have to draw the atomic structure of this. Then I'm saying argon 18. You have 1 minute to draw that write the electronic configuration of these elements using Bohr's and Bury scheme. Bohr's and Bury scheme, students. So for aluminium, what is going to happen? You have K shell, student K, then you have L, then you have M, first lower energy is always filled first, then we go to higher energy. How many electrons? 13. So in the first, how many you will put? 2 electrons, and after that 2 gone. 13 minus 2, how much is left? 11 electrons. And how many you can put in the L? Maximum 8. 1, 2, 3, 4, 5, 6, 7, 8, 11 minus 8. How many are left? 3. Then in the last, how many are going? 1, 2, 3. Okay? So we may write KLM283 for the aluminium. Okay? Students? Similarly, we can write for sulfur, chlorine and argon. What will be for sulfur? If I have to represent, like sulfur will be 286 KLM. These are the 3 shells. Chlorine will be, students, 287 and argon will be 288. Got it? Any doubt?
No, sir, no doubt.
And I said ki 8 is the maximum in the outermost. That means the 8 is maximum is called octet. You are saying 8 maximum in the outermost orbit. And this is what we call as octet. And argon, you can see argon has got 2, 8, 8. And this is very stable. Argon is very stable, student, very stable atom, and does not react. Stable mean it does not react. Does not react. This belongs to noble gas. Noble gas is inert. It is inert. It is inert because if 8 electrons are present in the outermost shell, it is stable. It is stable. But if 8 electrons are not present in the outermost shell, then atom will react. I am saying if 8 electrons are present, atom is stable. If 8 are not present, then atom is not stable. What we are saying, student, if 8 electrons not present, then atom is not stable. Not stable. If it is not stable, what it will do? It will react and will form molecules or compounds. It will react and form molecules or compounds. So, are you understanding me what I am saying till now? Tell me. Did you understand what I said? Then I will proceed.
Yes, sir.
Okay, keep on interacting with me. Energy should be high. जोर से बोलो, हाई एनर्जी. पता समझ में आया? आने तुझे समझ में आ गया मैं क्या कर रहा हूं? बोलो.
यस सर.
अच्छा, एनर्जी है ना, सोना नहीं है. देखो मैं एक एक चीज को एक्सप्लेन कर दूंगा. सारी एनसीईआरटी को डिकोड कर देंगे आपको. सारे क्वेश्चंस, ऑल क्वेश्चंस विल बी सॉल्व्ड एंड एवरीथिंग विल बी अंडरस्टूड कि कैसे लिखना है, क्या करना है. जो एनसीईआरटी में नहीं है वो भी मैं बता रहा हूँ. वहां पर एनसीईआरटी में बहुत कुछ नहीं है जो मैं आपको आई एम एक्सप्लेनिंग टू यू. सारी चीजें आपको पता लग जाएंगी स्टूडेंट्स. अब सारे राज खुल जाएंगे, सारी बातें पता लग जाएंगी. अब ये वैलेंसी क्या होती है स्टूडेंट? वैलेंसी क्या होती है? देखो अब हमने ये सारा कुछ क्यों बताया. हमने वैलेंसी क्या होती है? कंबाइनिंग कैपेसिटी ऑफ एन एलिमेंट. कंबाइनिंग, ठीक है, कैपेसिटी ऑफ कंबाइनिंग कैपेसिटी ऑफ एन एटम. देखो मैं व्हाट आई टोल्ड यू कि एटम जो है वो आर दे स्टेबल? फ्यू एटम्स आर स्टेबल. कौन से एटम स्टेबल है? जैसे हीलियम है, नियॉन है, आर्गोन है, इस तरह के ये जो एटम्स हैं स्टूडेंट्स, दे आर स्टेबल. हम ये कह रहे हैं ये स्टेबल है. स्टेबल क्या होते हैं कि दे डू नॉट रिएक्ट, दे आर नॉट रिएक्टिंग. आप ये कह रहे हो ये रिएक्ट नहीं करते, ये इनर्ट है. वाई? वी सेड बिकॉज दे हैव octet. What they have? Octet means they have 8 electrons in the outermost shell. इसको क्या बोलते हैं? ऑक्टेट. बात समझ में आई स्टूडेंट्स? इनके पास 8 इलेक्ट्रॉन है या इनका आउटर मोस्ट शेल फिल्ड है. अगर नियॉन का देखो, नियॉन का एटॉमिक नंबर 10 इलेक्ट्रॉन है नियॉन में, तो इसका क्या बनेगा? नियॉन का Kl28 बन गया. तो इसमें 8 इलेक्ट्रॉन है, तो ये स्टेबल है बिकॉज इट हैज ऑक्टेट. इसके पास ऑक्टेट है. समझ में आई? और अगर मैंने आर्गोन को लिखा, उसका एटॉमिक पास कितने इलेक्ट्रॉन थे? 18. तो 288 लिखा मैंने, Klm. इसके पास कितने हैं आउटर मोस्ट में? 8. ये भी स्टेबल है. और जिनके पास 8 नहीं है स्टूडेंट, वो क्या करेंगे? वो रिएक्ट करेंगे, वो कंबाइन करेंगे. तो कंबाइनिंग कैपेसिटी एलिमेंट्स की को हम क्या बोलते हैं? वैलेंसी. व्हाट इज वैलेंसी स्टूडेंट? वैलेंसी का मतलब क्या है? कंबाइनिंग कैपेसिटी ऑफ द एटम्स. तो एटम्स विल कंबाइन. तो अगर वो कंबाइन करेंगे तो क्या बनेगा? एटम्स विल कंबाइन टू फॉर्म, क्या बनाएंगे? मॉलिक्यूल्स और कंपाउंड्स. ऑक्सीजन एटम तो होता नहीं, लेकिन O2 डाई एटॉमिक होता है. O2 होता है. O2 आपको पता है ऑक्सीजन गैस है. नाइट्रोजन का आपको पता है गैस है स्टूडेंट. तो ये कंबाइन कर गया, नाइट्रोजन नाइट्रोजन एटम से कंबाइन कर गया स्टूडेंट, 2 नाइट्रोजन एटम कंबाइन कर गए तो क्या बन गया O2 N2। ये तो स्टेबल है, ये तो स्टेबल है। व्हाई डिड दे कंबाइन? क्योंकि ऑक्सीजन का कितना है बताओ, ऑक्सीजन का मैं अगर लिखूं स्टूडेंट, अगर ऑक्सीजन का लिखूं तो ऑक्सीजन का एटॉमिक नंबर 8 है, 6 है, तो ऑक्सीजन के पास क्या ऑक्टेट है? जल्दी बताओ, ऑक्टेट है? बोलो, है क्या ऑक्टेट? नहीं। तो ये ऑक्टेट पूरा करना चाहेगा इट, तो देयरफॉर इट विल रिएक्ट, देयरफॉर इट विल कंबाइन, इट विल कंबाइन। तो ये कंबाइन करेगा स्टूडेंट्स। तो इसको कितने इलेक्ट्रॉन चाहिए ऑक्टेट करने के लिए? नीड्स 2 इलेक्ट्रॉन्स टू कंप्लीट ऑक्टेट। बोलो सही है गलत है? जल्दी से बताओ। 8 होने के लिए कितने इलेक्ट्रॉन चाहिए? 2 मोर। तो ये कंबाइन करता है। नाइट्रोजन है, नाइट्रोजन एटॉमिक नंबर के पास कितने? 7 इलेक्ट्रॉन होते हैं, नाइट्रोजन का है 2 5। तो इसको भी देख रहे हो 3 इलेक्ट्रॉन की जरूरत है। हाउ मेनी इलेक्ट्रॉन्स आर रिक्वायर्ड फॉर द नाइट्रोजन? स्टूडेंट्स टेल मी, कितने इलेक्ट्रॉन ऐड करूं कि 8 बन जाए? बताओ, प्लस कितने इलेक्ट्रॉन ऐड करूं? 3। तो फिर क्या बन जाएगा? ऑक्टेट। तो ऑक्टेट हो गया, तो ये स्टेबल हो गया। तो ये नाइट्रोजन कंबाइन करेगा, कंबाइन करेगा। तो इस कंबाइनिंग कैपेसिटी को हमने क्या बोला स्टूडेंट? वैलेंसी। तो डिफरेंट एलिमेंट्स की वैलेंसी डिफरेंट होती है, उनके डिपेंड करता है कि हाउ मेनी इलेक्ट्रॉन्स दे हैव इन द आउटर मोस्ट शेल। स्टूडेंट्स बात समझ में आई? यस और नो? तो वैलेंसी
Yes, sir.
डेफिनेशन समझ में आई कि एटम्स कंबाइनिंग कैपेसिटी इज कॉल्ड द वैलेंसी। तो हाउ मेनी इलेक्ट्रॉन्स आर रिक्वायर्ड टू कंप्लीट एन ऑक्टेट। और अगर किसी के पास ज्यादा है, अब मैंने कहा सोडियम लेता हूं, सोडियम, सोडियम का फार्मूला बताओ स्टूडेंट, सोडियम का फार्मूला क्या? जल्दी से बताओ। Na। इसका, इसके पास 11 इलेक्ट्रॉन होते हैं, एटॉमिक नंबर कितना? 11। तो इसका क्या बनेगा? 281। अब देखो यहां पर 8 है, यहां पे 1 इलेक्ट्रॉन है, 7 इलेक्ट्रॉन को गेन करना मुश्किल है। लेकिन अगर ये लूज कर दे, अगर ये 1 इलेक्ट्रॉन को लॉस कर दे, लॉस ऑफ इलेक्ट्रॉन हो जाए, कितना? 1 इलेक्ट्रॉन का, तो क्या बचेगा? 28 बच गया। जल्दी से बताओ, यस और नो? बोलो,
Yes,
समझ में आई? तो ये ऑक्टेट हो गया, मतलब ये स्टेबल हो गया, दैट मीन्स इट बिकम स्टेबल। तो ये डिपेंड करता है कि इलेक्ट्रॉन कितने हैं बाहर। अगर इलेक्ट्रॉन 4 से कम या 4 होते हैं तो उनकी वैलेंसी उतनी ही मानी जाती है। तो इसकी वैलेंसी, मैं कह रहा हूं इसकी वैलेंसी सोडियम की क्या है? 1। सोडियम की वैलेंसी क्या है? हमने एक टेबल दिखाया था आपको, तो मैं ये लिखूं कि जो वैलेंसी है सोडियम की, वैलेंसी है सोडियम की, उसको कैसे लिखा था? +1। मतलब 1 इलेक्ट्रॉन लूज कर दिया, गेन करता तो माइनस होता, क्योंकि इसने 1 इलेक्ट्रॉन लूज कर दिया तो ऑक्टेट कंप्लीट हो गया। हो गया ऑक्टेट? यस और नो? टेल मी।
Yes, sir.
तो इसकी वैलेंसी कितनी होगी? +1। और अगर मैंने कहा ऑक्सीजन, मैंने लिखा था आपको ऑक्सीजन का, तुमने कहा 2 6 है, तो इसको 2 इलेक्ट्रॉन चाहिए। कितने चाहिए? 2। तो अगर इसकी वैलेंसी पूछूं तो वो कंबाइनिंग कैपेसिटी इसकी कितनी होगी? -2। मतलब ये 2 इलेक्ट्रॉन लेना चाहता है, इलेक्ट्रॉन का चार्ज माइनस होता है, तो -2 हो गई। तो इसने क्या बना दिया? -2 का मतलब इसके ऊपर ये -2 आ गया। तो अगर -2 आ गया तो ये 2 8 हो गया। 6 + 2 कितना होता है? 8। तो इसका ऑक्टेट पूरा हो गया। यस और नो? जल्दी से बताओ, समझ में आई स्टोरी?
yes, sir.
Yes, sir.
इलेक्ट्रॉन्स की कंबाइनिंग कैपेसिटी इज कॉल्ड द वैलेंसी। लेकिन वैलेंसी को पूरा, ऑक्टेट को पूरा करने के लिए स्टूडेंट्स एटम क्या कर सकते हैं? एटम्स ऑक्टेट, in order to complete their octet, student, atom can either share the electrons or can gain or lose the electron। मैं ये कह रहा हूं कि ऑक्टेट कंप्लीट करना चाहते हैं एटम्स, ऑक्टेट, टू कंप्लीट द ऑक्टेट स्टूडेंट, टू कंप्लीट द ऑक्टेट atoms can share electrons, शेयर कर सकते हैं, या एटम्स कैन लूज और गेन इलेक्ट्रॉन्स, गेन और लूज इलेक्ट्रॉन्स। तो जो वैलेंसी होती है, अगर मैं ये एटॉमिक डिस्ट्रीब्यूशन लिख दूंगा तो वहां से पता लग जाएगी रूल क्या बना। यहां पर हमने एक पॉइंट बताया, इसको नोट किया जाए स्टूडेंट। फॉर एटम्स हैविंग वैलेंस इलेक्ट्रॉन। वैलेंस इलेक्ट्रॉन कौन से होते हैं? इलेक्ट्रॉन्स विच आर प्रेजेंट इन द आउटर मोस्ट शेल, उन्हें क्या बोलते हैं? वैलेंस इलेक्ट्रॉन स्टूडेंट्स। यहां पे मैंने बताया व्हाट इज वैलेंसी, व्हाट इज वैलेंस इलेक्ट्रॉन। Electrons present in the outermost shell of atom are known as valence electron. These electrons will determine the valency of the atom. अब मैं कह रहा हूं फॉर एटम्स हैविंग वैलेंस इलेक्ट्रॉन लेस देन 4, वैलेंसी इज सेम एज नंबर ऑफ वैलेंस इलेक्ट्रॉन्स। जिसके पास 4 या 4 से लेस होंगे आउटर मोस्ट में इलेक्ट्रॉन्स, उनकी वैलेंसी विल बी सेम एज द नंबर ऑफ इलेक्ट्रॉन्स। लेकिन अगर 4 से ज्यादा होंगे तो वैलेंसी को निकालने के लिए हम 8 माइनस नंबर ऑफ वैलेंस इलेक्ट्रॉन कर देते हैं। क्या करते हैं? 8 माइनस नंबर ऑफ वैलेंस इलेक्ट्रॉन स्टूडेंट्स। तो इस तरह से हम उनकी वैलेंसी निकाल सकते हैं एटम्स की, जो हमने रूल बताया है। यहां पे समझ आई? बोलो।
Yes, sir.
अब मैंने क्वेश्चन लिखा डिफाइन वैलेंसी बाय टेकिंग एग्जांपल ऑफ सिलिकॉन एंड ऑक्सीजन। अब मेरे पास देखो सिलिकॉन है और ऑक्सीजन है, इसके पास एटॉमिक नंबर 8 है और सिलिकॉन का कितना होता है? ये होता है 14। तो इसका इलेक्ट्रॉनिक कॉन्फ़िगरेशन क्या बना? 2 6। इसका क्या बना? 2 8 4। ठीक है, KLM KL लिख दिया मैंने। बोलो सही लिखा गलत लिखा? जल्दी बताओ, राइट और रॉन्ग।
Right, sir.
तो हमने आपको रूल क्या बताया? हमने कहा कि इफ देयर आर 4 और लेस देन 4 इलेक्ट्रॉन्स, तो वैलेंसी कितनी होती है? वैलेंसी इज इक्वल टू द वैलेंस इलेक्ट्रॉन। ये वैलेंस इलेक्ट्रॉन्स हैं। ये कौन से हैं? वैलेंस इलेक्ट्रॉन्स। इसमें 6 हैं वैलेंस इलेक्ट्रॉन। इसमें कितने वैलेंस इलेक्ट्रॉन हैं? 4। ठीक है। इफ वैलेंसी इज इक्वल टू valence electrons, number of valence electrons, if it is equal to or less than 4, या 4 है, 4 से कम है, तो इसकी वैलेंसी कितनी होगी सिलिकॉन की? जल्दी से बताओ, इसकी वैलेंसी का आंसर कितना आया मेरा? 284 है। तो 4 या 4 से लेस वाली की वैलेंसी सेम होती है वैलेंस इलेक्ट्रॉन्स की। कितने वैलेंस इलेक्ट्रॉन है? 4, तो इसकी वैलेंसी 4 है। अब ऑक्सीजन का लेता हूं मैं। ऑक्सीजन में 2 6 है, तो यह 6 4 से बड़ा है या छोटा है? जल्दी बताओ। 6 इज ग्रेटर देन 4, तो इसकी वैलेंसी कैसे निकालूंगा? 8 माइनस 6 कितनी आई? 2। तो ऑक्सीजन की वैलेंसी कितनी आई है? 2। और सिलिकॉन की कितनी आई है स्टूडेंट्स? 4। समझ में आया कि वैलेंसी कैसे निकाली? बोलो यस और नो।
यस।
तो यहां पर हमने आपको दिखाया हाइड्रोजन है। हाइड्रोजन के पास सिर्फ एक ही इलेक्ट्रॉन है, एटॉमिक नंबर 1 है। इसके पास K में 1 है, तो इसकी वैलेंसी कितनी होगी हाइड्रोजन की? 1। तो एक इलेक्ट्रॉन शेयर कर लेगा, एक इलेक्ट्रॉन को छोड़ देगा तो कुछ भी नहीं बचेगा इसके पास। तो ये इलेक्ट्रॉन एक ले लेगा या शेयर करेगा, तो इसकी वैलेंसी कितनी हो जाएगी? 1। और सोडियम का मैंने कहा कि ऐसे दिख रहा है 2 8 1, एटॉमिक नंबर 11 है। तो इसके पास एक इलेक्ट्रॉन ज्यादा है। अगर ये इसने एक इलेक्ट्रॉन अपना लॉस कर दिया तो इसकी वैलेंसी 4, ये 4 से कम है, तो वैलेंसी कितनी है सोडियम की? 1। तो इस तरह से वी कैन फाइंड द वैलेंसीज ऑफ डिफरेंट एलिमेंट स्टूडेंट। इस तरह मैं अलग अलग एलिमेंट्स की वैलेंसी निकाल लेता हूं। मैग्नीशियम की वैलेंसी बताओ। लो क्वेश्चन आ गया। इसका एटॉमिक नंबर 12 है, तो कितना है? 282। तो इसकी वैलेंसी कितनी है मैग्नीशियम? जल्दी से बताओ, व्हाट इज द वैलेंसी ऑफ मैग्नीशियम? कितनी है? कितने इलेक्ट्रॉन है? वैलेंस में 2, तो वैलेंसी कितनी हुई मैग्नीशियम की? जल्दी से बताओ स्टूडेंट, क्या कितनी है इसकी वैलेंसी? ये 4 से कम है, तो वैलेंसी कितनी हो गई? 2। तो इस तरह से मैं निकाल सकता हूं। क्लोरीन का 17 है, इसका है 287 KLM। बताओ क्लोरीन की वैलेंसी कितनी होगी? वैलेंसी ऑफ क्लोरीन जल्दी से बताओ। Cl की वैलेंसी कितनी होगी स्टूडेंट? जल्दी बताओ। ये 4 से बड़ा है। 8 माइनस 7 कितना होगा? 1, तो इसकी वैलेंसी क्या हो जाएगी? क्लोरीन की 1। बोलो, कोई डाउट है? समझ में आया? स्टूडेंट्स की
Yes,
वैलेंसी
sir.
को कैसे निकालते हैं? इंपॉर्टेंट क्वेश्चन है, पेपर में आएगा स्टूडेंट्स। ये सारा कुछ नोट कर लिया। आज का लेक्चर बहुत इंपॉर्टेंट था। यहाँ पर हमने वी हैव टोल्ड यू हाउ द इलेक्ट्रॉन्स आर डिस्ट्रीब्यूटेड एंड हाउ टू फाइंड द वैलेंसी ऑफ द एलिमेंट स्टूडेंट्स। तो फिर मैं मिलता हूँ नेक्स्ट लेक्चर में। आई थैंक यू वेरी मच। आई विल मीट यू इन माई नेक्स्ट क्लास स्टूडेंट्स। ओके, बाय बाय एंड गुड इवनिंग। आप हमारे लेक्चर्स को शेयर करिए अपने फ्रेंड्स के साथ और सब्सक्राइब कीजिए यूट्यूब चैनल। ऑल द क्वेश्चंस ऑफ एनसीईआरटी of all the chapters will be solved for all the students who are appearing for the exam based on NCERT book. ठीक है?
Thank you,
Thank you,
sir.
sir.
Okay.